Hi, it's Fazana here. Welcome to part 3 of the higher GCSE probability questions. In this video, we'll look at even higher level questions. The questions, again, look tricky, so think logically, think realistically, try and plan as much as you can, and make the question come alive. So I'm assuming you know the basics of probability. If there's an event followed by another event, you multiply. And if there's an event or another event, you add. Okay, let's look at the questions. Exciting. Okay, bag A and bag B contain only red and green counters. Bag A has got 5 red and 1 green. Okay, bag B also has 6 counters. All right, okay, so the more you write, the more it'll actually jump out at you, whatever the question's asking you to do. Okay, so even these little simple things just make a huge difference, trust me. Okay, John takes 1 counter at random from bag A and puts it into bag B. Yeah. And then he takes 1 counter from bag B and puts it into bag A. Okay, bag A now only contains red counters, so you can see it must be the green one that went. Yeah? Okay, so as you're reading, can you see you're actually preparing? Yeah? The probability of this happening is 2 out of 21. Okay, so if the green one went there, for the bag A to only get red counters, there must be a red one from bag B going into bag A, yeah, for them to be all red counters. Okay, and that's the probability of it happening. So it's the probability of green from A followed by red from B. Green from A followed by red from B. Okay, yeah. How many green counters are in bag B at the start? So we want to know how many green counters there were in there at the start, okay, before that one went in. All right, okay, you must show you're working. Okay, so what's the probability of a green one going from A to B? So it would be 1 out of 6. Yeah. Now the probability of a red one going, we don't know the number of counters there. Yeah. So we're going to say X is the number of red counters. In B. Okay, yeah. So when we're looking at the green ones, we know we're going to do 6 minus the red ones will be the ones that are green. Okay, so again, you're just sort of planning and preparing. Yeah. Okay, so let's call the number of red counters X. So we've got X over. But now, can you see, because we took 1 green there, we actually have a total of 7 counters in here. Yeah? So can you see it'll be times X over 7. Yeah? That's why it's so important to draw. It's so important to make your diagram come alive. That's where the logic kicks in. All right, yeah, very, very important. Okay, so we've got X over 42 equals, and we've been given the probability 2 over 21. Now this is so easy because you can see you've multiplied that by 2, so you'd have multiply that by 2. So 2 times 2 is 4. So X equals 4, yeah, which is the number of red. Yeah, so green equals 6 minus 4, which is 2. All right, yeah, okay. Isn't that easy? Yeah, as I said, the questions themselves is just so um, so different. So all you've got to do is just make everything come alive and look at it really realistically and draw as much as you can, prepare as much as you can. Yeah? All right. Then the diagram becomes your own. Remember, that's where they got the question from. So you have to reclaim control of the diagram. All right. Good. Okay, next question. In the game of tennis, a player has two serves, and you can tell that's just so wordy, but we're just going to go in order and nothing's going to overwhelm us. All right. Okay, if the first serve is successful, the game continues. If the first serve is not successful, the player serves again. If the second serve is successful, the game continues. If both serves are unsuccessful, the player has served a double fault. Yeah, so successful, so I'm just going to put not successful. Yep, so you can see if it's not successful and not successful, then you'll have a double fault. Yes, I'm preparing something because this is all quite confusing at the moment, so at least I can write something. Okay. Pauline plays tennis. She's successful with 60% of her first serves. Okay, so we can do a tree branch with her first serve. Yeah. So the first serve, if she's successful, it's 0.6, and if she's not successful, it'll be 0.4. Okay, and 90% of her second serves. Okay, so let's look at that again. If the first serve is successful, the game continues. If the first serve is not successful, the player serves again. Okay, so then the second serve would be successful or not successful, and that would be 0.95, and that would be 0.05, because every branch has to total to 1. All right. Okay, calculate the probability that Pauline serves a double fault. So if it's not successful, not successful. So you can tell that would be 0.4 times 0.05. Remember that times is followed by, and you get 0.02. All right, yeah. If Pauline is successful with her first serve, she has a probability of 0.75 of winning the point. If she is successful with her second serve, then she has a probability of 0.5 of winning the point. Calculate the probability that Pauline wins the point. So what's the probability here? 0.75 to get the point. And here it's 0.5 to get the point. Okay, so you can see it's either that or that, and then we just multiply it straight across. So she's successful on her first one, so it'll be 0.6 times 0.75, and this one will be 0. There's a bit of a thing there, isn't there? 0.95 times 0.5. Okay, need to use my calculator here, so it'll take a while. Okay, so 0.66 times 0.75 is 0.45. And that one there will be 0.4 times 0.95 times 0.5 equals 0.19. And if we total it, because it's either that one or that one, plus 0.45, you get 0.64. Okay, so that's the probability she gets a point. All right, yeah, good. Mustn't forget that. For a while I just thought of that and that, but remember it's that, followed by that, followed by that. All right. Yeah. Okay. Good. And this one. Peter travels to work either by bus or by bike. Okay. It's terrible when they use B and B. The probability that Peter will travel to work by bus is 0.7. When he travels to work, so the probability of going by bike will be 0.3. So again, the minute I write something, I feel like I'm part of this question. Okay? When Peter travels to work by bus, the probability he will be late is 0.1. So I'm just going to put probability early equals 0.9. And when Peter travels to work by bike, the probability he will be late is 0.05. So the probability of early by bike is 0.95. Okay? Now this one is where it gets intense. Okay? Peter is going to work on Monday and Tuesday. So can you see there's the bus or the bike, there's late or early, and then there's Monday and Tuesday. Yeah? Work out the probability that he will be late for work at least one of these days. So you can tell to be late at least one of these days, then Monday, Tuesday, he could be late and early, or early and late, or late and late. Yeah, because that's at least one of the days. So can you see all these preparations are going on in order to establish what we're going to do? Okay, so how are we going to figure out the probability that he will be late on Monday? Because the probability he will be late on Monday depends on going by bus or by bike. Okay, so what we first got to do is find out the probability that he will be late on any given day. All right, so if he's going by bus or bike and late and early, late and early. Okay, so we're not thinking of the Monday, Tuesday right now, so that's just there once we do this. Okay, so we're just considering the probability that he will be late on a day or early on a day. Okay, so the probability he goes by bus is 0.7. So the probability he goes by work is by bike is 0.3. And you can tell by preparing it, you're not having to calculate it again. Yeah. When he goes by bus is 0.1 and 0.9, and we've already calculated those, and 0.05 and 0.95. Okay, so can you see the probability of him going late will be those two? Yeah, and so the probability of late will be 0.7 times 0.1 is 0.07 plus 0.3 times 0.05 is 0.015, and when you add them up you get 0.085. Okay, and then the probability of early will be 0.7 times 0.9 is 0.63, just underline that, plus the probability of early by bike is 0.3 times 0.95, which is 0.285, and that comes to 0.915. Okay, yeah, so can you see we had to calculate that first in order to then do that. So here now we can say it can either be 1 or 2 or 3. Okay, so the probability of 1 for him to be late on Monday will be 0.085 times early on Tuesday, 0.915. Yeah, once you've prepared, then it comes out really easy. Early, so you know it's just the other way around, times 0.085, or late on both days, so 0.085 times 0.085. And then if you put those all in your calculator, and you know you have to add because it could be that or that or that, you get this really long number. Don't round it unless they ask you to, because with probabilities you need to write down the whole thing. All right, okay. With everything else you can sort of round it to 2 decimal places, 3 significant figures, whatever seems suitable. Okay, but with probability, don't. All right, okay. So can you see this was a real intense question? You can do questions like this and nothing's going to phase you out. And once you do reach the end, you're smiling because you're looking around and saying, yeah, how many could do that? Yeah, okay, so I need you to smile as much in your exams because you're seeing questions that look really familiar to questions that you've practiced. All right, cool, brilliant. Okay, I hope that working out these questions seem easy now and you can approach it logically. It's great stretching the mind and realizing that you can do it. It's so satisfying, innit? I'll upload a part 4 when I find some more interesting questions, okay? And as I say, keep working hard. It's so worth it. And remember, you're in control, totally, completely, all areas in your life. Okay? All right. Take care. Until next time. Bye.